Hello everyone. In this video, we're going to look at a notation that we can use to simplify writing long sums, and that's sigma notation. So this big E shape is a Greek capital letter sigma, which is actually the letter S, and even though it looks like an E. And we use it to indicate a sum. So just some parts of the notation here. We have what's called an index variable, and I is a very common one, N is a very common one, J or K sometimes. So that tells me what variable I'm going to be using. That's going to be switching. And it's going to take on every value from this lower limit of 1, in this case up to the upper limit, which here, because this is 1 to 10, means I have 10 terms. The lower limit generally will be 1. Sometimes it'll be 0. More rarely, it'll be a different number. But that's the first number that you plug in for your index. And then this is the general term of the terms that we're going to be using in our series. So if it's an arithmetic series, that's going to be an arithmetic general term, geometric, or other. It's just the formula for how I calculate the different terms. So let's look at a specific example. So this one's going to be arithmetic because I have 2i minus 5, which is linear. To write this out in expansion, essentially what we do is we start with that formula and we start with the lower limit. And we replace I with that first number. So 2 times 1 minus 5, then 2 times 2 minus 5, 2 times 3 minus 5, and so on, all the way up to the upper limit, which would be, in this case, 2 times 6 minus 5. So if I actually calculate these, that gives me negative 2 plus negative 1 plus 1 plus etc. up to this last term, which is 7. We don't necessarily have to use the formula here because I only have 6 terms, so I could just figure out what all 6 of them are and add them together. But because I know that this is arithmetic, I know that the sum of these 6 terms is going to be 6 times negative 2 plus 7, first times the last, divided by 2. So if I know that my formula is arithmetic, I only need to calculate the first and the last terms, and then I can, and how many terms I have, obviously. So this is going to be 3 times 4, which means that the sum of these terms is all 12. Working the other way, if I have this sum, we just want to write it in sigma notation, so we want to shorthand it, which means I'm going to need a formula, and I'm going to need to know how many terms I have. So looking at this one, we multiply by 1/2 each time, so this is a geometric series. So in this case, if I think of this geometric series, Tn, the first term is 1/2. The common ratio is also 1/2. So the general formula is 1/2 times 1/2 to the power of n minus 1. Because I have 1/2 in both of these, I can combine into a single expression, 1 over 2 to the power of n, or if you prefer, 1 over 2 to the n. Either one of these is completely acceptable in your sigma notation. So that's my formula, 1 over 2 to the n. Now, I've used n, so I'm going to call that my index, and if I start at 1. But now I need to know what's the upper limit here. In other words, for 1 over 256, what is the value of n? So there's some value of n for which 1 over 2 to the n equals 1 over 256. So either knowing your powers of 2 or a little bit of trial and error, you hopefully realize that 2 to the power of 8 equals 256. So n equals 8 for my upper limit. And that is this sum expressed in sigma notation.